Hello everyone, today I am going to solve this problem. Please pause this video and read this problem very carefully. In this problem, a 50 kilogram crate is moving in downward direction as shown in this picture. So we have to find what will be the velocity of this crate when it will reach at the position B. The inclination, the path, have friction, and the coefficient of kinetic friction is given as 0.30. To find the velocity at position B, we can use the work energy formula based on the kinetic energy. So we will balance the work and kinetic energy on both position A and B. To calculate kinetic energy at position A, we can use the formula 1 by 2 mva square, and the values for mass and the velocity at position A is already given. Now we have to calculate the work from A to B. So we will try to look out what are the options or what are feasible work are available here. So we can see here that mass is moving downward direction. So we can say there is a work due to this gravity. And as per the problem, this path have friction. So we can say that there is some work associated with the friction. And as you know that the friction works against the direction of the motion. So here I will categorize the two works. The gravity, the work due to the gravity, it is mgh. The mass, the gravitational acceleration, and h. And this will be the positive. Why? Because this mass 50 kilogram carat is going towards downward direction. It means the work is towards the direction of the gravitational acceleration, downward direction. Now question is, what is h? So as I have earlier mentioned that in mgh calculation we always take this h in a vertical direction, the absolute vertical direction, as I have shown in the picture also. So you can use the formula, sine formula, and you can calculate the value for the h. The length of this path is already given, 10 meter, and the value for sine theta is given, that is sine 15 degree. So here you can write the values. 50 kilogram multiplied by 9.81 multiplied by sine 15 multiplied by 10 meter. Next, we have to calculate the work due to the friction. The friction works always against the motion of the direction of the motion. So in this case, the crate is going downward on inclined surface. It means that the work which will be applied will be minus and in the opposite direction of the motion. So first of all, let's see how to calculate work when there is a force. So the basic or fundamental formula is that work is equal to force multiplied by displacement. In this case, we have frictional force and we will multiply it with displacement. So I will write here Fk. Fk is a frictional force multiplied by the displacement. And always remember, what is this displacement? This displacement is always absolute. It means that we have to calculate or see how much displacement has been happened. If it is a linear, you can use simple line. You can just calculate. For this example, it is 10 meter. But suppose if it is on a curvilinear path, you have to calculate that curvilinear path. I mean the perimeter of that curve. So here things are very clear. It's easy. It's a simple linear path. So we can write the frictional force is frictional coefficient, kinetic friction coefficient multiplied by normal force. This is the formula, multiplied by 10 meter. Now the question is how to calculate this n. N is the normal force. So for this case, we have to make a free body diagram. So from the free body diagram, we can calculate the normal force working on this body. So suppose I am making a free body diagram here. The crate is shown here at position A. The normal force is working in the perpendicular direction of the motion. Always remember that normal or reaction force is always perpendicular. And in the yellow color, I put the mg. Mg is the force due to the mass of this body, and it is always in vertical downward direction, in the direction of the gravitational acceleration g. And Fk is always against towards the opposite direction of the crate. So you can see that I made a straight arrow which shows that friction force is working in a straight direction. So I hope this is clear, and theta angle is already given in the problem. So now we will balance the forces, and of course we have to find the normal force. So we will calculate what are the forces available in normal direction. Okay, you just have to focus in the normal direction. Okay, so here you can see in normal direction there is a normal force, and of course there is a component of mg. Okay, so we can write here n is equal to the mg component. Okay, now how to calculate this component? You have given angle, so you have to find what will be the angle. So I will write here mg cos 15. Now I will explain by a picture how I have calculated this cos 15. So now put the values here. In coming few seconds you will see that picture where it will be shown that how we can calculate the cos 15. For easy explanation, I have added this picture here, and you can see that mg is making 15 degree to the normal line. So you can calculate the component of mg in the direction of the normal force. Guys, we have just calculated the value for n as you have seen in the previous few seconds back. So based on the value for n, now we can calculate the frictional force, that is equal to the frictional coefficient kinetic multiplied by the normal force. And now I will calculate the work due to the friction. So I will write whole equation here, that is Fk multiplied by displacement. We have all values here. We have value for mu k, n, and the displacement. So 0.3 multiplied by 473.7 multiplied by 10 meter. This 10 is important As I said, it should be always the absolute length of the motion. If it is a curvilinear, you have to calculate the curvilinear path. Now look to our standard equation for the work and energy. TA plus UAB is equal to TB, so I will call it this equation 1. Now we have all values for the TA, for the work U and AB, and we have to find kinetic energy at position B, and from there we can calculate the velocity at position B. Now I will write all values for this equation. If you have any question or any problem from the dynamics book, please let me know in the comment section. I will try to solve it and upload on YouTube. Please also give your opinion on the quality of this tutorial. Let me know if something is missing or how it can be improved. So here I wrote all values just to remind you again that work due to the friction will be minus or negative. Now we can easily calculate the value for the velocity at position B. Solve it please by using your calculator. So the final answer for the velocity at position B is 3.15 meter per second. It is meter per second. Thank you very much for watching this video. Have a nice time, and please don't forget to like and subscribe. Have a great day.